I now want to look at how to find and explain equations for proportional relationships. We know that when we have two quantities that are varying together in a proportional relationship, if we know one quantity, we can find the other quantity using methods that we've been discussing. And so we can list many pairs of coordinated quantities in a table or a double number line. We can also express this relationship using equations very succinctly. Let's suppose we're making a new type of diesel that is 30% biodiesel and 70% petroleum diesel. And so we can imagine making almost any amount of this mixture, but in each mixture, the ratio of biodiesel to petrodiesel is 30 to 70, or equivalently 3 to 7. So I could use this to make a table where I have biodiesel on one side and petrodiesel on the other. So let's suppose I know some values for my biodiesel, such as 9, 15, 21, 24, and let's do some random amount B. Well, in order to find the petrodiesel, we can find this by using my constant of proportionality, or the value of the ratio, 7 to 3. Well, we can find our corresponding amount of petrodiesel by using a constant of proportionality, or the value of the ratio, 7 over 3, as a multiplier. So here we would have 7 over 3 times the 9 liters of biodiesel to get 21. We have 7 over 3 times 15. That will give us 35. 7 over 3 times 21. That would be equal to 49. 7 over 3 times 24. That would be 54. And in general, we would do 7 over 3 times B, and that will be equal to the amount of petro. So using this last row, we can kind of see that we can do 7 over 3 times B equal to P as an equation. So we can think of this equation as summarizing how the amounts of liters in petrodiesel given a number of liters of biodiesel. We could very similarly generate the equation 3 over 7p equal to B, where we pick numbers for petrodiesel and figure out the corresponding amount of biodiesel. And there are many other equations that relate these coordinated quantities of biodiesel and petrodiesel. And I want to point out some errors to watch for in formulating these equations. Let's suppose that we are making some chocolate and we need to mix cocoa to milk in a ratio of 2 to 5. So I'm going to let C stand for an amount of cocoa and M stand for an amount of milk. So one of the common issues is to start writing the equation as 2C, since we need 2 cups of cocoa. It's equal to 5M, since we need 5 cups of milk. However, that is wrong. You might ask why it's wrong. Well, we know that 2 cups of cocoa is equal to 5 cups of milk. So if I say we have 2 cups of cocoa, then we would have 2 times the 2 is equal to 4. However, that should also have 5 cups of milk. And 5 times 5 is 25, not 4. So this would not be a valid equation. In math, expressions and equations have very precise meanings. The equal sign means equals or is equal to, which is equal to. It does not mean goes together with or corresponds with. In addition, the 2C means 2 times C, which would be twice the amount of cocoa in a mixture. Because the cocoa takes up 2 parts, each part only contains half of C, not all of C. Similarly, 5M would be 5 times the amount of milk in the mixture. However, let's use a different letter. Let's consider the letter X. Let's let X be the number of liters in one part, either of cocoa or of milk. In that case, it's correct to look at it as the number of liters in cocoa as 2 times X and the number of liters of milk as 5 times X. So to show that these two quantities are mixed together, we can use a colon, 2x to 5x. However, it would be incorrect to write 2x is equal to 5x, so once again, that's wrong. Because the number of liters of cocoa do not equal the number of liters of milk. So that's what this looks at. This is the amount of cocoa and this is the amount of milk. And those two things are not going to be equal.